Hi students, okay, today in this lecture we discussing the topic is problems on jet transform. In the previous lecture we were discussing the basics formula, that is jet transform of the given sequence and basic formulas and formulas. So now we will do the problems on jet transform. So that is equal to a first one, find the jet transform of the sequence un is equal to 1 by n where n greater than 0. So jet transform of un is equal to summation n is equal 0 to infinite un into z power minus n, the basic definition. Okay na? Un is equal to 1 by n. So jet transform of 1 by n is equal to summation n is equal to 1 to infinite, because there is no starting 0, because n is equal to 0 is not defined here. So that is series is starting from 1. N is equal to 1 to infinite 1 by n into z power minus n. So substituting n is equal to 1 here. So that is equal to 1 by z plus 1 by 2z square plus n is equal to 3 1 by 3z cube plus up to so on. Okay, so that is equal to here, by expansion of the formula, one of the formula here which is can be right 1 by z plus 1 by z whole square by 2 plus 1 by z whole cube by 3 plus up to so on. Which form here? X plus x square by 2 plus x cube by 3 plus up to so on. So that is equal by using the formula. So this is the formula only. X plus x square by 2 plus x cube by 3 plus up to so on. So that is minus log of 1 minus x. So x is equal to the 1 by z. Okay. Now simplification is, so log of z minus 1 by z kada. Minus is interchanging numerator and denominator. That is log of z by z minus 1. So this is the z transform of 1 by n is equal to log of z by z minus 1. Okay. So next example here, show that z transform of 1 by n factorial is equal to e power 1 by z where n greater than or equal to 0. Since so z transform of un is equal to, by definition is substituting un is equal to 1 by n factorial. So that is equal to here. So expand here, n is equal to 0. The 1 by 0 factorial is 1. So n is equal to 1, 1 by z plus n is equal to 1 by 2 factorial z square plus n is equal to 3. 1 by 3 factorial z cube plus up to so on. So which is can be write in the form 1 plus 1 by z by 1 factorial plus 1 by z whole square by 2 factorial plus 1 by z whole cube by 3 factorial plus up to so on. Which form here? 1 plus x by 1 factorial x square by 2 factorial plus up to so on. That is equal to e power x form. X is equal to here 1 by z. That is e power 1 by z. So therefore z transform of 1 by n factorial is equal to e power 1 by z. Okay. So next one, find the z transform of the sequence n square where n greater than or equal to 0. So un is equal to n square. So by using the recurrence formula, okay, now this is one of the formula to finding z transform of n power p. So that is equal, substituting p is equal to here 2 because n square kada. So p is equal to z transform of n square. So that is equal z transform of n square is equal to minus z into d by dz of z transform of 2, p is equal to 2 minus 1 ante z transform of n. So that is equal to n minus z into d by dz of, already finding in the previous lecture, z transform of n is equal to formula z by z minus 1 whole square. So that is z by z minus 1 whole square. So now differentiation here, u by v method. Okay. So that is equal to u by v method minus z into z minus 1 whole square minus z into 2 into z minus 1 by z minus 1 whole power 4. So now here z minus 1 common is a cancel one term. Remaining here minus z into z minus 1 minus 2z by z minus 1 whole cube. So that is equal, after simplification is z into z plus 1 by z minus 1 whole cube. This is the z transform of sequence n square. Okay. So next one, find the Z transform of sin n theta and cos n theta. This is one of the important long question. So that is equal to sequence is sin n theta and cos n theta. So by using this formula, already finding here Z transform of a power n is equal to z by z minus a. Okay. So now substituting here a is equal to e power I theta. Put. So that is Z transform of a is equal to e power I theta. That is e power I n theta is equal to z by z minus e power I theta. So that is equal to here z by z minus e power I theta is equal to complex number cos theta plus I sin theta. So that is equal here, now separating real and imaginary part. Z by, so z minus cos theta is the real part minus I into sin theta is the imaginary part. So now rationalization the given term. So that is dividing and multiply with the z minus cos theta plus I sin theta by z minus cos theta plus I sin theta. So that is now multiplication is z into z minus cos theta plus I into z sin theta by, so this form here a minus ib plus a plus ib, that is a square plus b square form in the denominator. So a square means z minus cos theta whole square form here. Okay, z square minus 2z cos theta plus cos square theta plus b square means sin square theta. Okay, so that is equal to here, and z transform of in the LHS part e power I n theta is equal to cos n theta plus I sin n theta. So here z into z minus cos theta plus I into z into sin theta by, this is a simplification, z square minus 2z cos theta plus 1. So now on both sides equating the real part and imaginary part. Okay, na RHS is also same. So that is equal to here, so real part here z transform of cos n theta. So here real part z into z minus cos theta by z square minus 2z cos theta plus 1. Next imaginary part here sin n theta. So therefore z transform of sin n theta is equal to here z sin theta by z square minus 2z cos theta plus 1. Okay, na? So this is the z transform of sin n theta and cos n theta. So next one, find the z transform of sin h n theta. So sin h n theta is a hyperbolic function. Okay, na? So this is also important question. So given sequence un is equal to sin h of n theta. So by definition of z transform of un is equal to sin h n theta. So this is the un. Okay, na? So but by sin hx means hyperbolic function. By using that formula, so summation n is equal 0 to infinite, that is equal to here e power n theta minus e power minus n theta by 2 into z power minus n. Now separating here 1 by 2 is the common, 1 by 2 into z transform of n is equal 0 to infinite e power n theta into z power minus n minus summation n is equal 0 to infinite e power minus n theta into z power minus n. So that is equal to here, yeah, which form here, assumption here e power n theta means e power theta whole power n into z power minus n minus same e power minus n theta can be right e power minus theta whole power n, which form here, this is a power n again. Avuna, this is one of the sequence un, this is also a power n, a is equal to e power minus theta. So that is equal to, by using definition of z transform of a power n, avuna, a is equal to e power theta minus ikkada same z transform of a power n theta, a is equal to minus theta. Okay, so that is equal to here, by known formula z transform of a power n is equal to formula z by z minus a, ikkada a is equal to e power theta, that z by z minus e power theta minus this is z by z minus e power minus theta. So now simplification, take the LCM here, 1 by 2 into, so that is z square minus z into e power minus theta minus z square plus z into e power theta, that is equal to here. So after simplification z square is the cancel in the numerator, so z is the common e power theta minus e power minus theta by z square minus z into e power theta plus e power minus 2 theta plus 1. So observing here z into e power theta minus e power minus 8 theta by 2 is equal to manaki, so sin h theta on a numerator. So z into sin h theta by z square minus ఇక్కడ e power theta plus e power minus theta by 2. There is no by 2 means dividing and multiply with 2. So that is 2z into this is cos h theta. So this is the z transform of sin h of n theta is equal to z into sin h theta by z square minus 2z cos h theta plus 1. Okay, now so this is also important question. Similarly, we have to finding cos h n theta same. Okay, so next example here, find z transform of sin of 3n plus 5. So that is equal by definition is z transform of un is equal to summation n is equal to 0 to infinite un into z power minus n. Un is equal to sin of 3n plus 5. Okay, now so this is un is equal to, so now expand here sin a plus b form, sin a cos b plus cos a sin b gets sin 3n into cos 5 plus cos 3n into sin 5. Now separating the summation, cos 5 is a constant here, cos 5 summation n is equal to 0 to infinite sin 3n, so z power minus n. Okay, so next one here sin 5 is a common, the constant summation n is equal to 0 to infinite cos 3n into z power minus n. So again which form here, ఇది un కదా, అంటే z transform of un అంటే z transform of sin 3n అవునా. సో z transform of sin 3n, this is un is equal to cos 3n, z transform of cos 3n. Okay, so by using this formula already finding here z transform of sin n theta అంటే sin n theta, theta is equal to ఇక్కడ 3, ఇక్కడ theta is equal to 3 అవునా. So using that formula here substituting theta value 3. Okay, now so that is equal to substituting theta is equal to 3 cos 5, so z into sin 3 by z square minus 2z cos 3 plus 1. So ikkada cos 3n means z into z minus cos 3 by z square minus 2z into cos 3 plus 1. Now simplification is take the LCM here, z into sin 3 cos 5 plus, so z square into sin 5 minus z cos 3 sin pi. So after simplification is z square into sin 5 minus z into sin 2 by z square minus 2z into cos 3 plus 1. This is the required value of z transform of sin of 3n plus 5. So another example here, find z transform of nck where 0 less than or equal to k less than or equal to n. So by definition here, but here given sequence is in terms of k and n, and the k values changed, so 0 to n. Okay, now z transform of this is uk assumption not un in terms of k term sequence. So that is equal summation k is equal to value 0 to n, the finite value. uk means nck z power minus k అంటే un ప్లేస్ లో uk అనమాట, అంటే n ప్లేస్ లో k ఇచ్చారు ఇక్కడ మనకి, డిఫరెన్స్ both are same but variable different. Now expand here k is equal 0, nc 0 plus k is equal 1, nc1 1 by z plus nc2 1 by z square plus ncn 1 by z power n. So that is equal to 1 plus, so by using binomial theorem అవునా, 1 plus x power n, ఇక్కడ x is equal to 1 by z, so 1 plus 1 by z whole power n. So therefore z transform of nck is equal to 1 plus 1 by z power n. Okay, so this is the practice problems. Okay, so this is the problems on z transform. For more videos please do subscribe my channel, like and share it. Thank you.